All right, so what I've done is I've calculated what happens if you invest $5,000 for different compounding periods. So at the top, I've got compounding only one time per year. If I compound quarterly, how many times is that in a year? Okay, so how long is a quarter?
3 months.
3 months, not 4 months, 3 months. All right, monthly is 12. How many fortnights are in a year?
26.
52 weeks in a year. One fortnight is 2 weeks. So 52 divided by 2 gives you 26. All right, so a couple of things you should notice from this table. As I go down the page, the amount of money I earn in 1 year goes up. Right? The more often I compound the interest, the better the return I get at the end. So I'm going to introduce in a moment a new concept called the effective interest rate. And that's the formula on the board. And I'm not really going to explain where that formula comes from. I just think it's going to take a bit too long. But I'm going to try to show you what it's about using this table. So the first thing I want to do is I want to ask you, looking at this first number here, let's say I invest $5,000 into the bank and I get 6% interest at the end of the year. So my new balance after 1 year is 5,300. The question is, how much interest did I earn? 300. Okay? It's how much money was added to the accounts. All right? So, here's what I'm going to do. I'm going to calculate the interest in each case. So again, you can see the interest is going up each time. And this is what the effective interest rate is about. It's saying how much interest do you earn in 1 year? And you divide that by the amount at the start. And you convert it to a percentage by multiplying by 100. So if I do 300 divided by 5,000 and multiply that by 100, I invite you to do this calculation. You will actually get 6%. Okay, so now that's the same as this. Let's watch what happens when we do something shorter than a year. So let's take 306.82, which is what we get if we invest in a quarterly compounding account. If I do 306.82 divided by 5,000 and convert that to a percentage, yep. I'll do a couple more. I won't do them all. Okay, so year 12, please listen carefully to this. So um, what this is saying is, let's take a look at this last number here. If I invest in daily compound interest for 1 year, this is saying it's the same as investing in 6.18%, with only one payment at the end of the year. So if I invest in an investment that gives me 6% interest compounded daily, that's like 6.18% after 1 year. So one of the problems is if I compound with different periods, it's not exactly clear how much interest I'm going to get unless I do the full calculation. But if I just tell you the percentage on the right, then you'll know how much interest to expect at the end of the year. And so this is really what effective interest rate's about. Okay, let's do one more example. Okay, have a look at this example, guys. What do you notice? Before I teach you how to do this question, what do you notice?
That has gone down.
Okay, so daily, the interest rate is smaller. So normally you might think, oh, the interest rate is smaller, so that's worse, right? But we've got to be careful. The second option has more compounding periods. So it could be better because of this effective interest rate thing happening here. See how 6% changed to 6.18%? All right, so we've got to understand that even though it's 5.5 and 5.4, the actual interest that you earn is going to be slightly different to those numbers.
Excuse interruption. Tom Clark, please come to the office. Tom Clark, please come to the office immediately. Thank you.
Okay, so the way that we compare different interest rates with different compounding periods is with something called the effective interest rate. So I'm going to introduce you to a formula, and then I'll introduce you to something on the CAS calculator. So here's the formula, okay? The effective interest rate, and I'm going to say you don't need to understand where this comes from, but if you want me to explain it to you outside of class, I'm happy to do so. So you got a bracket there, and you got another bracket on the outside, and then you multiply by 100%. Looks pretty ugly, right? So you can either use that, or you can use this. On the CAS calculator, you've got a function called EFF for effective interest rate. So, because my textbook's being used, I'll pull it up. It's all right, Tim. Okay, so if you've got your CAS calculator, pull it out. And what you want to do is go to Finance, so Menu. So Menu, Finance, Tom, Harry, I hope you're following us, because I don't think you are. Okay, the nominal interest rate is just the annual rate. Okay? So that was a good question, Jazz, because I've actually only used the formula up until this year. So the nominal interest rate is the annual rate. So it's what you've been given here, 5.5 and 5.4. Okay? Now, when you use this function on your CAS calculator, you need to give it some information. So you need to tell it the nominal rate. So the first one will be 5.4. And you need to tell, or was it 5.5? 5.5. And then you need to tell it how many times you're compounding. So if it's monthly, you'll compound 12 times. If it's weekly, you'll compound 52 times. If it's daily, you'll compound 365 times. All right, so go ahead and do that and see what effective interest rate it spits out. Okay, so you've got the CAS calculators. So what's the effective interest rate when we do 5.5% per annum monthly? 5.640. Yeah, that's fine. And what about the second one?
6, 7.
Yeah. Okay, so year 12s, I'm just getting the sense that that you're not listening. So I'm going to draw your attention back to the board. I gave you two investments to look at. 5.5% monthly, 5.4% daily. And I posed the question, which one was better? Which one will give you more interest in the long run? The way we do that is by converting both to the effective interest rate, because now it doesn't matter that the interest rates are different and the compounding periods are different. Now it's on a common scale now. So now we can compare them. Which one's better?
Sorry. The daily, sorry, I forgot to change 12 to 365.
Okay, so what is it?
Monthly 5.54, right? 0.36.
Okay, so daily, you get more interest more often, but Anthony, you were saying monthly was better. Higher percentage. Yeah, this one is better. So, as we finish up with this section, Year 12s, this is a pretty common exam question. They give you 5 options with different interest rates and different compounding periods, and they ask you, which one is the best option? Harry? They give you 5 different options, different interest rates, different compounding periods, and then they ask, which one's the best option? What you want to do is convert them all to an effective interest rate and pick the highest one. Okay, so you don't have to use the formula because you've got the CAS calculator. Okay, the formula is provided on the formula sheet that you get at the end of the year. But last year I only taught the formula, and that upset a few students. So this year, I'm choosing not to focus on the formula, just use the CAS calculator to get the effective interest rate. Okay, so that's it for 7F. I will test you on all of Chapter 7 next Wednesday. So you've got plenty to go on with over the weekend. You have got about 20 minutes left, so please make good use of this time. If you've got questions, let me know. Thank you.